Yesterday Shane came over from Leicestershire and he dropped in personally his Midland 4001 for service. And if I could find a knife on this bench or similar, we could probably get into the packet. Instead of which we'll use a screwdriver. He's even got the power lead. But he hasn't got a fuse, so I'm required to fit one. Original mic. Now folks, when sending radios in, don't send brackets or side screws because they go astray. Okay, we'll cope with it from there. So he says it transmits and receives, but it's not right. Put those out of the way as well, or they'll get catapulted off the bench. So we have a January 1982 Midland 4001, and these were in the 89.99 to 99.99 category at the time. When Plustronics went bankrupt, Dixon's, which is the Curry's Dixon's Curry's group, bought the remaining stock and were able to sell off the remaining stock of Midland 4001s for just $29.99, which unfortunately they were selling sets from $9.99, and this got people on CB who otherwise wouldn't have been on CB, and not necessarily the best type of breakers. And there you are. So let's take this apart. I think we have to put the soldering iron on for a Midland and unsolder the speaker. Yes, we do. The only problems I seem to have is the antenna warning indicator, and that's been gone over for dry joints, I can see in the past. This gentleman's a licensed radio amateur. He's a G7, so that goes back a few years, and I must have a chat with him over 70 centimetres, which is my favourite and virtually the only band I bother with. Right, has that soldering iron warmed up? I'm going to change glasses. So the only thing which I've found happens with these is the discriminator or the detector coil down there goes out of alignment in over time. So we will see. I'm just looking if I can see the protection diode. Yeah, it is intact. In fact, we could test for it, couldn't we? So if I leave the radio off and we're going to diode test, it may well be presented across the, and it is, and the diode's in place. This is going to be fun. Crocodile clip to crocodile clip, uninsulated. Going to really enjoy shorting my leads out. We need the, yeah, we do, we need that extension speaker, and we need the test instrument into there. Now I switched on the test instrument only 10 minutes ago, and it's half an hour before you do any frequency alignments, but we'll look into that. Pop the voltage to 13.8. So, squelch to minimum, RF gain and mic gain to full, filter out, dimmer off, DX, CB. We'll put picture in picture on. I'll tell you what, we'll make some notes as to what it's doing right now. So transmit. Well, that's alright, it's 4.4 watts. Deviation. Wow, it's a bit high. I mean, that's a bit high, that both need to come down. Frequency, so we can't check properly. Within tolerance, but I've got to do that right now, but I'll readjust it off camera right at the end, or check it. There we go. So here comes the receive. No, he says people saying he doesn't sound right. Well, there's no reason why he shouldn't. You know, I've pulled up the frequency, but it wasn't out. It wasn't out off specification. It's just to have a listen to what it sounds like on our monitor receiver. Testing 1 2 3 4 5 5 4 3 2 1. No, there's nothing wrong with that. Lots of these people are using illegal radios, and so a radio that is legal will be off frequency to a lot of illegal radios. Why have I suddenly got no sound? turn the volume down. Anyway, this is the important one. So let's go over to our SINAD meter. And we will put 27,79125. Oh, I wouldn't say it's that bad. So for 12 decibel SINAD, it's 0.75 microvolts. They can usually do better than this. But I wonder if the detector's out and it sounds lousy because of that. So I'll put the oscilloscope on and we'll just have a look at that. I know I do these in a particular sequence and we're not doing that, but I'm just curious as to why it's here. So if I go to the detector coil, the trouble is it's under that wiring. No, it was actually spot on. So that's not the reason either. Okay. Well, it's the best working CB we've had in for repair for a decade. Okay. So we'll run through the transmitter. See if we can remember without getting the manual out. So although it's doing 4.4 watts and needs to come down, conversely we need to make sure it's correctly peaked. I think that's in the transmit chain. That one was slightly astray. So we want to adjust this one but not the next one. So the next one's the harmonic trap for the second harmonic. So I'm going to leave it at 4.1. So we're not doing that one, otherwise we'd be putting on the spectrum analyzer, and there's no reason to do that because it's never been messed with. So let's have a look at the deviation, because that's a bit out, as in too high. And I've got to remember which one it is. Is it that one? Yes, it is. Testing 1 2 wallow, wallow 1 2 1 2 wallow. Actually, it's too low now. Let's try it there. 1 2 1 2 wallow, 1, 2, wallow. Yeah, that's where, that's there. I'll just check the frequency once again. That's fine. So I'll do that off camera later just to make sure. So, is the meter on the front reading what it should do? I think it's that one at the back which does the meter. Well, that's saying well over, so we'll just bring that down to just under the 5 there, rather than it banging across. These don't have low power, which was a bit of a cock-up because they were required to provide low power, and if anybody had moaned, they would have had to have been modified free to include a low power switch on the back. I've never seen that modification, but that is something which Midland had to have available for free. Or they'd have had their license revoked. So, what does that bring us to? You know what, we've done the transmitter because there was nothing wrong. Yeah, just tidied it up, haven't we? You know, got the meter readings not banging across. So we'll go over to receive. Just need to check whether that one's receiver transmit. Transmit, we'll go back to transmit. That's fine. So, have we got the SINAD meter on? No, we haven't. So we'll run through this receive. Oh wow! Oh, he's going to please. That's come up considerably. It wasn't out of spec, but any improvement's great. So as the signal comes up, we drop down the attenuator on the signal generator. We don't want to saturate the receiver. Let's put a bit more signal on for that IF one there. Spot on right. We've already done the detector, so there we are. Let's take a reading now. So it's 0.75 before. Let's get that. Can't quite get on that scale. Let's go on this scale. It's about 12. Wow, it's 0.34. Excellent. So we'll now put the signal generator to S9. So it's 100 microvolts on the UK CB radio. And we want the needle to read S9. It's reading just under 7. Now, not all these have got a preset. And you get what you're given. That's going to be Squelch, so it can't be low power because it doesn't have low power. So is this the meter? Yes, it is. So that's now on the 9. Squelch. So let's turn the signal generator down. Turn the squelch to full. Turn the signal generator up. I want it to come in at 100 microvolts. So it's an S9 equivalent. No squelch. Doesn't matter how high I have the signal generator, it never comes in. So that's really wrong. That's now in at the right point. So 100 microvolts, drop it down so that it goes off. Advanced 3 microvolts, 10 microvolts, 30 microvolts, 100 microvolts, and in it comes. It's pointless having a squelch which never ever opens. So hopefully we've got that right. I'm going to put the signal generator to standby, which is what that red light tells me. We'll turn the, not the volume, the squelch to threshold. Switch the signal generator back on. It'll just set its level. It actually comes straight in. So it's coming in at 0.27 of a microvolt, and it's leaving at 0.22 of a microvolt. So that's a really nice squelch. Good. I'll put squelch max 100 microvolts. Done that. Now then, does this SWR thing work? I'll spend more time doing this AWI is what I mean, antenna warning indicator. I've been spending more time on that than the whole of the rest of the set. So what we need is our antenna matcher. So there's a patch lead. I'm going to need a patch lead. You know what? While we're messing about with this, let's get that Zitagi meter out, because we all enjoy fictitious fairy tales on power. See how many Zitagi watts it's doing. So it's doing 4.1 on my Marconi test set. Got dummy load in the back, that into the transmitter. Key up. Oh, he's doing 5.5 on the Zitagi meter. So put that back. Oh, I do like that. Can you imagine, can't you, being in a shop and you go, well, I wonder if you want to buy this second-hand radio. It's working great. Look, it's doing 4 watts. And, you know, the radio's doing 2.5. I think that's probably what they do. So we will, using the SWR176, which is a trough line made in Japan meter. I think we're going to have a quick talk about these, because I've had another query on SWR meters. I don't think there's any current ones which are using a trough line, because it's expensive to make them. I'm talking about CB meters. I'm not talking about something from commercial radio or ham radio. So we need to have the matcher off, and we need to be, we're in 5 watt mode, and I'm going to key up. And according to this meter, If we're in the 5 watt range and we're in power, then I don't get this. I don't get how the reading can be. I mean, that's saying we're doing just over 6 watts, which is, of course, is a load of bull. But if that's the 5 watt range, why does it read 10? Why is 5 there? I'm not sure. It's a bit weird. Anyway, so our SWR, let's do forwards. Just to show you the SWR of the test set is under 1.5. So, well, it's less than that. It's just, I think the meter's got some loss in it. Switch the SWR this on. And now we'll adjust this meter. For a worse SWR. Actually, all I can get is 3 to 1. Ah, there we are. And at that SWR, the antenna warning light's coming on. So that's great. So switch the matcher back off. So we're back to a perfect SWR, and the antenna warning light isn't on. So it's actually one that works, and it's adjusted right. So it's the preset there, and we'd want that light to come on with an SWR probably about 3.5 to 1. So there we are. I was able to achieve that. Good. Well, I don't think we need to plug the radio back into the test instrument anymore. I will do later, as I say, just to check the frequency. I'll do this bit about SWR meters, and then I'll come back to this in half an hour. But you won't see a change in the video. That's the magic of it. Right. So SWR meters. That's one that's lurking up there. Here's another nice one. So that's an audio line one, and once again this is a trough line meter. I'm going to open this one up just for the video. One of the cheaper makes, like Binatone, I think did a trough line meter. I think all the Micron to Tandy ones, and remember I'm talking about UK, there may be Micron to ones in other countries that were a load of rubbish, but in the UK they offered 2 models which were both very expensive. One had 3 meters and was really aimed at the AM because it had modulation, which of course is talking about AM modulation, not about FM deviation. I don't know how we kind of get this off, but I'm sure I can force it apart with a big screwdriver. Okay. So in here, you've got some wiring, you've got the diodes which do the sensing, you've got a variable resistor potentiometer, you've got some resistors and some more diodes, and you've got a capacitor there. But in here, this is a trough line. You've got some Paxilin spacers, and these are Lecher lines. L-E-C-H-E-R, Lecher lines. And these are a calculated length. And of course they radiate into each other, but they don't push interference out through that trough line. So it's all well calculated, and these are the best type of SWR meters to buy. They're the best accuracy. Having said that, I mean, it's saying we've got 1.5 to 1 SWR, which I actually doubt. Perhaps there's a preset you can adjust. But anyway, by and large, these are the best type to have. Mind you, it wasn't this one. It was the other one, wasn't it? Which told me I've got. I'll tell you what. We'll try this. We'll put this on because I don't quite know what's inside that matcher one. Put this back together. Now, if you take the lid off most SWR meters, there's just a printed circuit board inside, and those lines are etched into the printed circuit board. So it certainly makes them repeatable, but they're never going to be that accurate. It's not really the best way to do it. But this is, you can imagine these have to be hand assembled. There's nothing in here which, you know, is going to be put together on a machine, so it's going to make these inherently expensive. I actually think the Micronta one was $29.99, which, you know, was a lot of money. And when you consider there were £6.95 ones out there which used the printed circuit technique. So we'll just plop this one on. I mean, I hope this is a worker now I've told you all that. So we'll plug that into our test. Oh yes, that's the aerial end. These came with a little screw-on aerial to go into the field strength test. They're always missing, and you end up having to just shove a crocodile clip in and hoping for the best. So I'll borrow that patch lead back. Is it fun experimenting with somebody else's radio? So on this one, it's showing my SWR is perfect. No movement at all. Unless that meter's not working. Just for a moment, I'm going to unplug from the test set. Yeah, there we go. So it's absolutely one-to-one. So clearly that one with the built-in matcher isn't that accurate. But that is the bee's knees. And there are other ones. I think even. Hey, you know what? Is that a realistic one there? Oh, it's another of those. Another of those ones. 175. So I expect. Now I've discussed these, that when you see one on eBay, snatch it. The other type has a single meter, and it's same case, knobs at the bottom, meters there, and I think Binatone did one like that. I don't think there's one kicking about, but that's another one with a trough line in it. Now, if we move on to the current ones and some of the cheaper ones at the time, I may just have to go on a little hunt. Okay, so 20 minutes has elapsed since, and I've checked the frequency on the radio. So this is a current model, CRT SW1. They do a one with a built-in field strength meter, I seem to recall, and we've got that one somewhere. I think they're about £15 these days. CE approved, and let's see what the SWR shows on this. So forward, the set line, reflect, 1-to-1. So that accuracy seems to me to be pretty good. So let's open this up. Because this is a current model, I bought it last year just to do a demonstration of the kind of SWR meter current scene. I think we've still got some Altai ones of these still in stock. Now, it uses a printed circuit board, and the parts are mounted on the printed circuit board. But I tell you what, I mean, I say that and it seems to be more accurate than these normally are, so that seems to be one of the better cheap ones. These are the kind of thing that was $6.99 in 1981, but of course they're not now. Pop that one together. Okay, so here we are on the aerial. So you can probably see why they had the meter set to be rather less generous than it should be, because it's got an internal residual racket of S3, and even with the RF gain turned down, that's internally generated rubbish. So you can see why they've done that. Anyway, we've got it set right for S9, and that's what we're here to do. 19 Roger. There we go. Nobody on. Isn't that great? Now, somebody said, oh, put your aerial high. We don't want the aerial higher. We know the aerial on this building is good for 35 miles. CB radio, according to our government, is supposed to be a up to 16 kilometre range two-way radio service. So we're getting 35 miles. We're getting a lot more than what it's supposed to work at, quite legally. And so we don't want the aerial any higher. All it means is there's nobody on with a half-decent aerial within 35 miles. So there we go. So what can we say? I mean, it's a feature pack set, and 39 years later, it's still working a treat. And although I was starting to think, what on earth is it coming for service for? Because the transmit, all we've done is to actually end up turning it down. But as far as the receive go, I think we've really made leaps and bounds from 0.75 of microvolt down to 0.334 microvolt, and of course we've reset that squelch properly. So there were a couple of things there which were issues. And they probably are about 35 miles away. I don't know why we've got picture-in-picture still on. So, we'll be doing an on-the-air test later. Thanks for watching. And I think we've got a brand new set which is coming from the wholesaler yesterday to look at this afternoon. So, is it any tone? Probably. Thanks for watching.